This config lab can be kind of tricky because you have to work through the EUI-64 process in reverse. So I'll show you the answers, but we'll focus on the process and looking in detail at those interface IDs so you understand EUI-64 better. Let's jump in. In the books, if you look in Volume 1, Part 7, Chapter 27, you can find all the content about IPv6 address config. Video-wise, you can look in that link just above my head and down in the description for more details. Here's a direct link to the lab. So if you go to that link, you'll open a blog page, and on that one page, you find all the details for the lab. So if you go to that page right now, you'd see the scenario and tasks and topology diagram, and then a suggestion to stop and do the lab in Cisco Packet Tracer and experience for yourself. And then at the bottom of the page, it gives you the literal answer for the config plus some explanation as to why I believe that to be true. So you could totally just use the blog page. However, there's an intro video if you haven't noticed it. It should be linked in the description and up above my head right now. Also, this video is a review video. These videos go into more depth and give a little different take on things than the blog page, but definitely more depth. So use those if you like, or just use the blog page. All right, let's get into the review video and get into some depth on what happens in this lab. Here's the original topology. You can see this same diagram or one like it in the blog page. Here's the table of desired IPv6 addresses on each interface, again from the blog page. Now, here's the important marching order for the lab. This is the end result of the address we want on each interface. Your job is to figure out what MAC address, once the router applies EUI-64 logic to it, will give us these IPv6 addresses. So you're reverse engineering or reversing the process of how EUI-64 works. For example, if we took the desired address for R1's gig01 interface, which is repeated here in its abbreviated form, here's the process I showed you in the intro. I use the same example, by the way, where you expand to include all the zeros, so the expanded version of the address, where the first half is the prefix on the left and the part on the right is the interface ID. Then we just get rid of the prefix to focus on the last 16 hex digits, which are the interface ID. Then we invert the third bit and the second digit. That is the 7th overall bit. In this case, it changes hex 0 to hex 2. And then that fox, fox, fox easy in the middle of this 16-digit interface ID, we get rid of that, which leaves us with our 12-digit MAC address once it feeds back into the EUI-64 process, which is the reverse of what we just talked about. That'll give you the correct interface ID in your IPv6 address. Let me walk you through the literal answers for a moment. Here's R1 and R2, and you can hit pause and look at those if you want. These are the correct answers for real gear. All right, so I told you that the bit flip is incorrect in Packet Tracer in some cases. These would work correctly on real gear, irregardless of Packet Tracer's problems. You can also find these answers on the blog page, by the way. Here are the correct answers on R3 and R4. Again, you can hit pause, look at them here, look at them on the blog page. Now, I'm going to walk you through things in the demo and look at these in a little more detail with show command output that shows the results. Additionally, as a reminder, these gray ones, R1's second interface and both of R2 and R3's interfaces work correctly in Packet Tracer. So when you're testing, your math should work out correctly. The other three interfaces, though, that bit flip is incorrect in Packet Tracer, so the interface ID's second hex digit will be off compared to real gear. To that end, I'm going to start by demoing with R2, then R3 because it works just like real, and then I'll circle back to R1 where we get one of each, and I'll leave router R4 as an exercise for you. All right, let's get into lab. Here's the lab topology. So what I've done is I've downloaded the file that you could download from the blog page to start the lab, and then I copy and pasted in the answer configs for the 4 routers into the 4 respective routers here in lab. So it's basically what you download plus the correct config. And I'm going to start on router R2. Now, I did that so I didn't want you to have to sit there and wait while I type and typo all those config commands, but I'll do a show run just to start out here. Let's see. Let's look at the part of show run for interface gig01. And here we've got the MAC address command, and we've got the IPv6 address. Now the IPv6 address command ends in EUI-64 in this case, which means by requirement, we can only configure a prefix, not the whole address. And then the router is going to do that EUI-64 math. It's going to take the MAC address. Now, normally it would take the burned-in MAC address on the interface, but we've overridden that to say use the one I've highlighted on the page there. So that's the hard part of the math, right, is picking that number. So what did the router come up with starting with that MAC address? Well, we should see an interface ID that's almost identical to that MAC with a fox, 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 easy in the middle of it. So to see those, if you do the command show IPv6 interface, and then point to the interface ID, this same interface ID that we saw in our show running config output, what do we get? Well, here's our global unicast address. Now notice it begins with 2000::, which matches our abbreviated prefix from the config command. What else do we see? We see this 16-digit. Now, this one's 16 digits because there's no way to abbreviate it. If there were some zeros in there, it'd be abbreviated. It'd be less than 16 digits, but a 16-digit interface ID that is almost identical to the MAC address with the fox, 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 easy put in the middle. So if you look at the last 6 digits of the MAC, ED chicken 724, look here, ED chicken 724. If you look further, there's our fox, 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 easy, whoops, in the middle of the interface ID, and then this value that's begins Charlie 281 is very close to the first 6 digits of the MAC address, but that second hex digit of 0 with the bit flip becomes a hex 2, and there's our evidence of the bit flip working. All right, so that's the math you would have worked through to get this correct answer. Also, link local addresses by default. Routers use EUI-64 logic to come up with their interface IDs. Notice this highlighted 16-digit interface ID matches our global unicast address EUI-64 calculated interface ID because they're using the same process based on the same MAC address. Now, if you wanted to make sure all this looked correct, you could go back to the blog page and look at our proposed set of 8 addresses per the marching orders and confirm, yep, that global unicast address is indeed the one that the lab said we want to appear at the end of this process. Whew, that's a lot, huh? Now, if we did the same thing for interface 2 and we look at the configuration down here at the bottom, we see a MAC address command that you would have calculated for lab, and we see the IPv6 address command with the EUI-64 at the end. And if you work through this same process and compare it to the output, oops, where'd it go? There it is. Here, what do we have? Well, here's our global unicast address on interface gig02, the second half of which is the interface ID, and we notice the fox, 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 easy in the middle. You notice the ending 6 hex digits. Chicken Easy A103 match the MAC address of Chicken Easy A103 up above that we configured. And the 6 digits just in front of the fox, 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 easy 7 able 24 fox baker is close to 78 24 fox baker. What's different? That second hex digit of 8 in the MAC address went through the bit flip process and became an able in the interface ID. All right, so that's what we're wanting to give you some repetition with so you get more and more comfortable with EUI-64. For router R3, it's a similar process, just different details. So if we look there and we use the command to look at the running config for gigabit 0/1, we see these 2 configured commands, right? We see the MAC address, and again, we're overriding the burned in MAC address so we can end up with the correct EUI-64 calculated IPv6 address. And here's our IPv6 address command with the EUI-64 keyword. Now, in real life, might you have just said, hey, let's just configure the whole thing statically and not use this keyword? Sure. but we're exercising our skills on this to be ready for the exam. So how do we see what the router calculated? We do show IPv6 interface and give it the interface ID. And here we see the global unicast address, which was calculated with those EUI-64 rules. And if you doubted that, the fact that it has a fox easy right there in the middle of the interface ID should confirm that. And we see this same interface ID value in the link local address as well, because by default, routers use EUI-64 to calculate the interface ID for those addresses as well. So where did we end up? Well, check out this MAC address we chose in this case. I've highlighted it up there above from the configuration output. And if we look at this interface ID portion of the output of the global unicast address, we see the number that exactly matches the second half of the MAC address. We see the fox easy. And then we see a number that's almost identical to the first half of the MAC address, except what would be that second hex digit is flipped from a 0 to a 2. Then if we do the same process with interface 2, here's the configuration. We've got this MAC address with no zeros, so it doesn't abbreviate much when you get it into the IPv6 address. Here's our IPv6 address command with only the prefix but not the interface ID configured. So what do we end up with in our show command output to compare it? Well, we've got this global address. There's the full address, the second half of which is the interface ID with the fox easy in the middle of the interface ID with the final 6 digits matching the configured MAC address exactly. And the 6 hex digits just in front of the fox easy, almost exactly matching the MAC address. Just that second hex digit is changed because of the bit flip logic. So hopefully it's starting to become comfortable as far as what the steps are, but obviously you need to dig in and do this on paper to convince yourself you've come up with the right answer. Now let's talk about R1. R1 on its gig01 interface, it has an unfortunate MAC address value in that the packet tracer feature where it won't flip a binary 1 to a 0 for EUI-64 is shown. All right, so let's just walk through it and make that clear. So here's our running config output for gig01. And here's our MAC address command. Now, it turns out if you were to look at these first 2 hex digits of 02, that 7th bit is in the second hex digit. It's the 3rd bit in the second hex digit. And that hex 2 in binary is 0010. In other words, the overall 7th bit is a binary 1. So when EUI-64 takes this MAC address and says, hey, let me invert that 1 to a 0, packet tracer doesn't. Real gear would, a real router would convert the binary 1 to a 0. Packet tracer won't. So let's see that in action here on the interface. So if we look at the interface ID portion and look out here at the front, it says 200. Now remember how IPv6 abbreviates by removing leading zeros in a quartet? So now I want you to envision that not as 200, but 0200. So we get 4 hex digits in this quartet. So there's 0200. And look back at the MAC address, 0200. So nothing got converted in the second hex digit in this case. All right. Picture 0200, so you've unabbreviated the IPv6 address. 0200 in the original MAC address wasn't converted. Everything else is there. We've got the fox easy in the middle. We've got the ending 345678, easy to remember as the second half of the MAC. We just don't have the inversion of the bit, as I said, because of this feature of packet tracer that's different than real gear. If you go to the blog and you look at the desired IPv6 address, it's not this number, right? It's the number for which if that 2 had its 3rd bit flipped and turned into a hex 0, then that's the number that we've asked for. That's the number a real router would have calculated. All right, so there's one example of it. R4 has two more if you want to just be aware of that for your further study and examination. The other interface on router R2 though, or excuse me, router R1, let me get it up here, there we go. Show running config, there's its MAC address and its IPv6 address command. And there's its EUI-64 calculated interface ID. Notice the first half of it, Able Easy 13 versus Able Chicken 13. So clearly that bit flip has happened in that second hex digit. In this example, switching it from a binary 0 to a binary 1. Hope you enjoyed doing the lab as well as hearing about the lab. So if you're new to the channel, please subscribe and click the bell and hear about new content like this. As always, let me know what's on your mind, share the videos, all those things help me out. I appreciate the help. Hope you're doing well. Talk to you soon.